Good morning, students. Our today's topic is homologous series. Students, a homologous series is a series of compounds that have the same functional group and each member differs from the next member by a CH2 unit in their formula. Means, in homologous series, all members can be represented by the same general formula. For example, the general formula of the homologous series of alkane is CnH2n plus 2, where n is any integer. So in all full series, all the compounds will follow the same formula. Next characteristics of homologous series is each member of the series differs from the members before or after it by a CH2 functional group. Means if we are comparing the first and second member of any series, which is homologous series, then we will find that in the second member one carbon and the two hydrogen will increase. Third is all members of the series possess similar chemical properties as they have same functional group, right? Next, all members of the series show a gradual change in their physical properties as their molecular masses increases. In general, as molar mass increases, melting point, boiling point and the density increase. So these are the characteristics of homologous series. Student, in this chapter we have to study about the homologous series of alkanes, homologous series of alkenes and series of alkynes. And here we have formulas for alkane, alkene and alkynes. For alkanes we have a general formula CnH2n plus 2. Here n is actually the number of carbon. Alkenes CnH2n and for alkynes CnH2n minus 2. Before starting the series, student, we should know what are the hydrocarbons. A compound containing only hydrogen and carbon is called hydrocarbon. Like methane, ethane, propane, butane, these all are the hydrocarbons. There are two types of hydrocarbons, saturated and unsaturated. Saturated hydrocarbon contain the maximum number of hydrogens, single bonds between all carbons. And these are called alkanes with the general formula CnH2n plus 2. The next is unsaturated hydrocarbons, which contain one double or triple bond. If hydrocarbon contains double bond, it is called alkene. And if it is containing triple bond, it is called alkyne. So here we have some root words which are actually the prefixes which you use to give name to the hydrocarbons. If in a compound of hydrocarbon we have one carbon, means number of carbon is 1, then we use the prefix meth. For 2 carbon eth, 3 carbons prop, for 4 carbon bute, if the carbon number 5 then pent, for 6 carbon hex, 7 hep, and this for 8 oct, for 9 non, and the for carbon 10 dec. These all are the prefixes. And the suffixes we are using according to the alkane, alkene, alkyne. Means if a hydrocarbon is containing all bonds single bond, means if it is alkane, then what we do, we will use the suffix ane. So if the meth is there, so it will just combine with the ane and convert into the methane, right? So here we have a first series, homologous series of alkane. Now we know that the formula for the alkane is CnH2n plus 2. So if we have a hydrocarbon in which number of carbon is 1, so we will get the formula CH4. And as just now we have discussed that if the number of carbon is 1, we use the prefix meth, and it is alkane, so the name is methane, right? If suppose the number of carbon 2, then we will get the formula C2H6 and the name is ethane. With the 3 carbon, the name is propane, then butane, and then pentane, so on. So what we observe in this series, CH4, C2H6, C3H8, C4H10, in this full series we will find the first difference between the first member and the second member. We will find this is the difference of CH2, 1 carbon and 2 hydrogen, and in molecular mass it is the difference of 14. So this is the series which is called homologous series of alkane. Likewise, we have a series, homologous series of alkene. As I told you, the formula for this is CnH2n and 1 double bond minimum. And it starts with the 2 carbons. And the formula with the 2 carbon is C2H4 and the name is ethene. Because this is alkene, so we will add the suffix "ene". With the 3 carbon, it is propene. With the 4 carbon, butene. 5 carbon, pentene, and with the 6 carbon, hexene, and so on. Right? Next is the homologous series of alkyne. So definitely suffix is "ine", formula is CnH2n minus 2. So it also starts with the carbon number 2. So what will be the formula for this? C2H2, 1 triple bond. Eth is the prefix and we will add the "ine", so the name will become ethyne. With 3 carbon, it will be propyne. With 4 carbon, butyne. With 5 carbon, pentyne, hexyne, like this, so on. So in this series also we observe the same thing. The difference between the members is CH2, 1 carbon and 2 hydrogen. So these series, all series are called homologous series of hydrocarbons.